Hi everyone, welcome back on my channel. Today we have the next case study video, and today we will talk about data engineering for supply chain optimization. Let's start as usual with problem statement. In this case, in supply chain management, raw data comes from multiple sources, such as warehouse, ERP systems, and sales database. To make data useful for reporting, analytics, and forecasting, we must perform data engineering tasks, including cleaning, transforming, and structuring of the data. Let's talk about the common problems with the data. So we have data inconsistency, different formats across sources like CSV, Excel, JSON, SQL, data redundancy, duplicates record from multiple systems, missing on current values, gaps in transaction logs, incorrect products codes. Then we have incorrect data types, numbers stored as text, incorrect data formats, outliers and anomalies, abnormal sales or inventory level. Then we have slow processing, inefficient ETL, extract, transfer, load pipelines. And proposal solution for those, we create a Python-based data engineering pipeline that extracts data from multiple sources, cleans and transforms data, handling duplicates, fixing type, nudging missing values, detects and handles outliers using the hierarchy method, loads the clean data into structured form, for example, SQL database, Parquet file. This automated pipeline ensures high quality, consistent, well-structured data for business intelligence machine learning models. Okay, this is that was the theory. Let's jump to the code, to the Python code. We start as usual with important libraries, in this case pandas, numpy, and SQL3 for storing process data in the structured database. And the step number one is data structure, so load data from multiple sources. Supply chain data comes from different sources, right? It can be CSV, the warehouse inventory, Excel sales report, JSON, API logs from ERP system, SQL database, historical transaction. And our goal is to extract and merge them into one unified dataset. So this is like the example how we can load the data. So we'll load a warehouse inventory CSV file with PD read CSV, then load sales data with pandas read Excel, API logs with pandas read JSON, and load historical transaction SQL database. We need to use SQLite connect, then some query. I put select all from the transaction, and PD read SQL query and the con. So the connection. Then let's merge all this into one data frame. In this case, I create df data frame is equal to pandas concat, and I put all of the created data sets and it with ignored index like true. After we have the data, we can start to cleaning it and pre-processing. So cleaning steps: handle missing values, convert data types, remove duplicates, standardize text format. So what we have here, we are checking for missing values, so fill na no. Then we're converting order ID and SKU code to string, so as type str for order ID and SKU code column. Then we are converting order date column to data format, so pandas to datetime, column, arrow, squares. Then let's go to convert numeric fields to correct format. So quantity and price, pandas to numeric, then our columns and arrows. Let's then go to remove duplicates records, so data frame, drop duplicates, subset order and SKU, keep first and in place true. The last step is to trim space and standardize capitalization. So for data frame, let's apply data frame, apply map, lambda for strip upper, if in existence, x string, else x. So to be sure that the data is trim. Let's go now try to find outlier detection and handling using hierarchy method. Outliers in sales, inventory level, and pricing can distort analytics and will detect outliers using the interquarter range method. Okay, so let's create a function to detect outliers. In this case, I will create Q1 data columns quantity 0 to 25, then Q3 0.75. EQR is equal to quarter 1 minus quarter 3 minus quarter 1, and then we calculate lower bound and upper bound. We return data frame for column is lower the lower bound or is bigger than upper bound. So the text outliers in the Q numerics column, in this case the text outliers in quantity and the price, and we're marking outliers with lambda in this and our calculation for quantity outlier and price outlier. Then let's jump to data transformation, so creating new features. In this case, we transform data to improve its usefulness, compute total revenue per order, and create order month and year for trend analysis. So let's create total revenue, which is equal to data quantity column multiplied by data price column. Then extract year and month from data type. In this case, from order year and order month is equal to order date, and then dt and the year, dt and the month. Step number 5 is load clean data into SQL database. So the cleaned and structured data is stored in a SQL database for further analysis. In this case, we connect to database, so con cleaned SQL connect. Then we save the clean data, so data frame to SQL, and then close connection cleaned and close. Step number 6 is to save clean data for the further analysis. We can save the clean data set in multiple formats for different use cases. So SCV for light web processing, Excel for business user, Parquet for big data processing. Now here we have the proposal, right? So data frame to CSV, data frame to Excel, data frame to Parquet. And the final output and summary. So in this case, we have summary of the data engineering process. So what we did is to extract data from multiple sources, clean missing values and fix incorrect formats, remove duplicates and standardized text, detect and flag outliers using EQR, create new features for analysis, store and clean data into SQL, CSV, Excel, or Parquet. Then process data is now ready for the analytics, machine learning, and reporting. And last thing, the last part of the code is the print. We printed data engineering pipeline completed, clean data set successfully. Okay, and that should be it for this video. Thank you for watching.